I am at EICMA event in Milan, and this is the most insane, intense, the biggest e-bike motorcycle event in the world. You have here all the latest, the most advanced bikes and all accessories that you need for 2 and 3 wheels. The amount of bikes and e-bikes here is insane. I am in one of these hangars and each one of them is huge. It feels like half of the mile each way, and there's 5 buildings this size. You can easily get lost here. Guys, I was planning to come to this event for the last 3 years and finally made it this year. And this place is just insane. Look at the stuff here. And Honda is announcing their electric motorcycle here. Also, ultraviolets here. Look at this, guys. If you ride and you like motorcycles, you have to come see this. Any e-bike, scooter or motorcycle, it does not matter how powerful, how fast or how much range it offers. If the battery is not strong enough, you know how it will play out and how it will perform. Today, I would like to introduce you a new brand for US market that has been in the Asian market for decades. A leader in battery production. This is Ampace, and they're unveiling a new line of batteries for 2025 that will revolutionize electric mobility. Ampace is a joint venture between ATL and CATL. It is a company focusing on advanced lithium-ion battery development storage system, a brand that has been on the market for the last 3 to 4 years and have over 50 big conglomerate business partners using their battery systems and customized manufacturing platforms, advanced real-time intelligent data analysis, and fully automated energy storage system that I cannot disclose. But the smaller ones that I'm allowed to show you and mention for you so you have an idea are CF Motor, Sunrun, that we all know and ride, V-Motor, just to name a few. And I have reviewed Neo Bike a while back, and I was looking at the battery and I saw that this is made by Ampace. Here's a quick glimpse at the presentation and unveil, and after, I got a chance to speak with Dr. Yuan, Ampace CTO, and get some more information about the new lineup and talk in detail about what's coming in 2025. That's Sunrun. That bike is very popular and the models are coming, and now there's so many different competition, different brands like E-ProRide, like Altris, and there's so many different configurations, and everybody wants to keep the bike light and get performance. But everybody, after they buy the Sunrun, they upgrade the battery because the battery is not enough capacity, not enough discharge. People want to have power. And there's so many third-party companies that are upgrading 72 volts from lower voltage into 45, 50, 60, 70 amps, and they put adapters just to make the bike, to last longer. So we need to show them what is the battery, what makes it special, right? What's the difference? Because I saw in the presentation you have extra safety features, you have higher discharge, longer runtime, and you comprime and make it more compact, more smaller. I know this is not real batteries because it's not allowed to have batteries here, right? But I want you to walk me through first safety, what's different, 2, and 3, what's coming in the future.
Safety is our top priority. You know that the battery is kind of an energy storage system. When we talk about the safety, we not only talk about the safety at the beginning, for example, like the overcharge test, nail test, whatever. But when we talk about the safety, we focus on the whole service life. That's why we did a lot of internal tests. Yeah, longevity. For example, if the cell can support, for example, 3,000 cycles, usually at the beginning we do a lot of tests. When run in the middle of the life, for example, like the 500 cycles or 1,000 cycles, we stop the test. We do the cell disassembly and check everything. Make sure that the inside, the material are healthy.
It's not degraded, right?
Yeah. Then, when the cell at the end of life, we also do the tear down analysis. That's how we put the safety as in our mind, because we need to consider the whole life cycle, not only just the beginning.
Yes.
Yeah. The different stage, when we check the safety, we have a checklist. We do a lot of things. Some are from the micro level, some are from the micro level, like the nano size and
micro and macro.
Yeah, micro and macro.
Small and yeah.
Yeah. So the only purpose is to make sure we want to know the details how each component behaves. So that's the first one, safety, and the second is the reliability. In our company, we think that the reliability is kind of quality over time. usually people buy a new thing, everything is good, but over time, for example, 1 year or 2 years later, they don't want too many troubles, right?
Problems, yeah.
So that's why we do a lot of tests, like the moisture, like the
Water resistance.
yeah,
right?
water resistance and the drop vibration. Yeah, that's kind of to simulate the real working profile.
Yeah.
So that is the second reliability. Also, we internally we have a very large lab to do a lot of tests, mechanical, electrochemical, and EE, electrical, different kinds of tests to simulate the different scenarios. So that's the second one. And the third one, we also are pursuing the ultimate user experience. As I mentioned yesterday, user experience, usually people think it's good or not good just based on their feeling.
Yeah.
So we are wondering how to make them feel good. Usually they feel because from what they see, what they touch. Yeah. So
How they feel about it, yeah.
Yeah, how they feel about it. Their feeling will give them the conclusion. So we are thinking, how does the customer or end user feel? Before we launch the product, the market, we have our engineering to do the feeling experience. You try to act as our end user to put the battery into the electrical motorcycle to see how does it fit well or not fit well. Also, like the handle is robust enough or not. So internally, we do a lot of things to make sure that the end user experience is as good as what we expect.
And the sizes, this is very important for me. I see you guys have a new size, right? 35 is the width, right? And 205 is the length, right?
Yes, this is the diameter.
Yeah.
35.
And
Yes.
this is the length, right?
Yes.
So why this size? What's special about this?
Yeah, that's a very good question. And at the very beginning, we internally debated a lot. What kind of the size will be the future standardized size? So we do a lot of market survey and discuss with our customers. We cannot cover each type, but we will cover most likely more than 85 to 95%
of the
Yeah, that's our major market. So we do a lot of analysis for their electrical motorcycle compartment, to see what kind of size is the best fit. And finally, we determine this area.
So this is laid down this way, right?
Yes.
Okay.
That is the sail, right? Then put it in this way.
And you can put it laying down, you can put it standing up, and it's pretty compact, I think, right?
Yeah.
You can put it this way, you can put it that way. So yeah, it makes sense.
Yeah.
30 kilograms. 60 amps. This is pretty big battery, yeah.
Yes, maybe 4 kilowatt hour, right?
4 kilowatt, yep.
This is current 60.
It says here.
This is voltage.
Oh, voltage.
This is
60 amp hours, yeah.
Yeah. So the energy is 74 times
60, yeah.
Almost 4 kilowatt hour.
Yeah. It's actually more than 4 because 6 by 7, 42, so it's 4 plus kilowatts, yeah.
Maybe
it's 4.2, 4.5 kilowatts, yeah. Yeah, it's a pretty big, yeah. It's a decent size, but you also have here the BMS, the indicator charger, connector, the standard connector, yeah.
Yeah, we also standardized the charger, the connector to make sure. For this form factor, we can not only fit the cylindrical and also the pouch and also the prismatic. When we do the design at the very beginning, we have already considered all the different form factors.
What's the advantage in the pouch versus cylindrical or versus prismatic? What's the difference? What's the advantage and disadvantage?
Usually for the pouch and the weight usually is lighter than the cylindrical.
I see.
Yeah, generally. But for the cylindrical is kind of more standardized. But for this type, it's customized it's defined by us.
You can do the different setups. I see.
Yeah. So usually for the chemistry, they are mostly the same chemistry.
And what kind of chemistry are you using this?
Here, our chemistry is called the BP. BP is a new chemistry developed by ourselves. It's kind of, we use a different cathode material, anode material, electrolyte additive, and also the conductive agent. And that kind of chemistry is different from our competitors available in the market because that chemistry will balance the safety and the energy density. Usually for the current product, the main chemistry is the lithium iron phosphate. That kind of chemistry, the energy density is much lower.
It's much lower, yes.
Yeah, another typical chemistry is NCM, nickel, cobalt, manganese.
What Tesla's using,
Yeah, that chemistry, the energy density is higher, but the safety is lower.
It's low, yes.
Yeah, so this is our combination. We take the most advantage of the safety of LFP and the high energy density of NCM.
I see, yes.
So that's our BP
So it's
chemistry.
a mixture of both, yeah.
Yeah.
Pretty
So
cool.
it's kind of well balanced between the safety and energy density. And in the meantime, we also our chemistry can deliver a very long cycle life, more than 3,000 cycles at the room temperature. Let me give you some. Let me make you have more sense about what does the cycle means. For example, if you run the battery 1 cycle per day, that means after 1 year you will get 360, right?
Yeah, 1 days, yeah.
Even after 5 years, that means the battery will run more than 1,500 or 600 or something. But our battery can last more than 3,000. That means even you run the battery.
That's almost 10 years.
Yeah, almost 10 years.
Yeah.
Also, another factor is the temperature. For example, in the summer, temperature is not high, like the 25 degrees C or even lower. That temperature is very good for the battery performance. But in some conditions like the South Asia, Dubai or something, their weather is much hotter.
Yeah.
So even under the 45 degrees C, that kind of much harsher condition, the battery can still run more than 2,000 cycles. That means 5 years performance delivery is not a problem. So considering all the different locations, the regions, their temperature profile, I think we are pretty confident for their 5 years performance delivery.
I see. And I think you have here. I remember yesterday was 51. This is all 51 volts,
Yeah,
right?
51.
So you have 51, 60, right? 51 volts, 60 amperes.
Yeah,
You have 74, 45, 60, and this is 28, right?
Yeah, 74, 28.
I have a cake motorcycle, and I'm thinking the battery I have right now, if I go full power, it gives me like maybe 25 miles in range, maybe 22, 23, depending how hard I push. If I go on the highway, maximum probably 15, 18 miles. And I'm thinking it's 51 volts and 50 amps. And I think it's this size. I think it's maybe even bigger. So this is 10 more amp hours, and I think it's smaller size. So
This is the capacity.
60 amps, yeah.
Ampere hour.
60 amp hours, yeah.
this
So I'm
is
thinking I actually want to get one and put in my bike and test to see the difference, because if I get 10 more amps and better efficiency, that's going to give me at least 10-15% more range.
Yes.
So I actually want to try this. But where do you see the future of the e-bikes, e-motorcycle? Where do you see all the industry going in the next 5 years, 10 years? How do you see the future? Is the battery going to get smaller, more density, more voltage, more performance? Will be allowed to charge faster? Where do you see everything going?
Yeah, I think thanks to the government policy and everyone is looking for the future for the green energy transformation, right? I think most of the factories they transfer from the gasoline to the green energy. I think this also fit for the e-motorcycle field. So basically, the customer they are pursuing for higher performance and lower cost, right? Everybody wants they're looking
smaller
for
battery, smaller weight, smaller size.
Yes.
Yeah.
And I think for us, we need to make sure battery is full of energy. We need to manage very carefully. So I think we always need to be very careful when we show our respect for the battery system.
For power, yeah.
Yeah.
But do you have any advancement? Are you testing any solid state technology or any new technology? Is anything that you guys do in the lab that's different, that may be coming in 5 years or 10 years? Do you have a vision about that, or anything, any comments you can comment about?
Internally, we do have a team to develop the next generation technology, like the semi-solid batteries, and also the pure solid state batteries. I think maybe in some market, for example, like the ICT, like the laptop or smartphone ICT market, some semi-solid battery has already been manufactured, implemented. But for the pure solid-state battery, they still need some technology breakthrough because the biggest challenge is the resistance between the interface. Because the solid and the solid, the interface resistance is much, much higher. I think most of the scientists are working on that.
So it's not yet working, okay.
Yeah, not working yet. So for the future, they are going that direction. But I think for the pure solid-state battery, still takes some time.
Sometimes it's not ready yet.
Not ready yet.
So this chemistry is going to be, for the near future, still going to be around, and we're still going to use this, right?
Yes.
Is there any way you guys see in the next 1 to 3 years to increase capacity and decrease size?
Yes.
Is it possible?
Yes, we do. For the size, we are not going to change. We want to keep the standardized size, but we will upgrade the chemistry.
The chemistry, so it's more density and less weight,
more
right?
density, right.
Yeah. I see.
Also, when we do the system design, the system can support the different pack in parallel. For example, if you think that like this pack is still, the energy is not still good enough, you can extend the energy by different packs in parallel. Maybe. I
mean, connect in parallel, right?
Yeah, connect in parallel. So it not only can support 2, but also can support 4.
Yes.
So if one pack is 4 kilowatt hour, 4 packs means that more than 12, right?
Yes.
4 plus 4, yes.
Yeah.
16.
Yeah.
So I think that's big enough.
So the thing is, for me, what's important is I visually feel that this is almost the same battery as cake, maybe a little smaller. So I think I'll be able to fit inside. Mm-hmm. And there's many more out of motorcycle in different configurations. But I was thinking, it's cool to have this because I have 10 amps more capacity. But also, I think here it's cool that I can swap quickly and I can continue riding. But let's say if I have to go from my home 50 miles away and I can't stop and I can't have a second swap, right? And I can only get 25. I think having in a year or 2 and 3, because I think every year is like 3-5% increased capacity in technology. I think keeping, as you mentioned, the same shape, the same size, the same standard, but increasing density, let's say maybe next year will be 75 or 70 amps, is going to give me so much more in 1 year span or 2 years to increase, and I don't have to change the motorcycle, I can change the battery and keep the same. I think that's what people will enjoy and will like and hope to get this sooner, faster.
Yeah, as you said, I think one of the most important direction is continuously increase the energy density. Meanwhile, when we increase the energy density, also
safety.
Yeah, the cost also goes down per 1 hour, right? Because the housing, everything is the same.
Yeah.
So the energy goes
You don't
up.
have to manufacture, you don't have to produce and create, change the factories, change the tooling and everything.
We should always keep in mind this. We need to really put the safety as the core. Otherwise, more energy means more energy inside.
More power,
if you cannot well manage, that will be a
disaster.
Disaster for the end user.
Yeah, I've seen a video. Somebody made a custom motorcycle like 8 or 7 years ago. It was an old video, an endless sphere, and the guy had a battery which was like 2 times bigger, and it was a racing event, and the battery ignited, and there's a fire truck next to it, and for an hour they dumped water and they couldn't put it off. This is so much energy, so much power. If you don't have a good BMS and good management system, it's a disaster.
That's why we always we need to show our real respect for the safety, not only just at the beginning, but also the whole service life. So when we do the design, I think the first one we need to consider what kind of chemistry we need to choose, and the second one we need to think in some extreme conditions. That's why, as I showed in yesterday's video, we do a lot of some very extreme conditions. We cannot guarantee how the end user use our battery.
Yeah, absolutely,
Yeah, and the bottom line, even in some worst case, the battery will catch fire. But we want to design a venting path to make sure that the explosion or combustion will not hurt the user.
Yeah.
So that's our different basic design guidelines.
Absolutely.
Yeah.
Thank you so much. This was awesome. Thank you. The safety features implemented by Ampace with the new safety increased thresholds levels, it's outstanding. Denting the case so much and not compromising the safety? No more concerns for daily use with rain, car washes, or even submerging at 1 meter underwater, the battery will operate. Under extreme stress testing for 3 days underwater, removing the top cover, it does not cause safety issues. Pushing the boundaries up to 75 degrees Celsius and getting the battery to operate at 45 degrees and get over 2000 cycles is incredible. And this is super important. Ampace found an optimal cell size and mixed chemistry to offer us the best possible performance in a motorcycle platform versus cost, not compromising safety. I have not heard or seen anybody else in the industry doing this extreme test and offering features and these levels of safety. The 2025 battery lineup for sure is what we need. Guys, I cannot wait to get these batteries and test them for you and share the results. Thank you so much for watching until the end, and I'll see you next time.